So we were looking at arc length and curvature. And two things I wanted to tell you. The curvature of a straight line is 0. Okay, so the curvature okay, so we have a straight line. All right, so the straight line always points in the same direction. So let's see. So we have R of t is x naught plus at I plus y naught plus bt j plus z naught plus ct k. So now we need to find r prime. All right, well, that's simply going to be ai plus bj plus ck. All right, so that's r prime. And so therefore its length, this is actually, remember, v of t. So nu of t equal to the length of v of t is going to be the square root of a squared plus b squared plus c squared. Okay, so that's good. So therefore the unit tangent t is simply 1 over that thing times v, which is ai, no, Dawn, get this right. That goes over the I. Nope. Okay. Plus bj plus ck. So notice the unit tangent vector is a constant. What's the curvature? The curvature says find the length of t prime of t over the length of v. But t prime of t is 0i plus 0j plus 0k. So it's the 0 vector. So when I take the length of that, that's just 0. So therefore my curvature turns out to be 0. Okay, so that's the first thing. And the curvature, number 2, the curvature of a circle of radius a is 1 over a. Okay, so let's say I give you something. So here is r of theta. Is equal to a cosine theta I plus a sine theta j. So it's just a plain old circle. And I'm going to parameterize it in terms of the arc length S. So S is the arc length. So therefore, I'm going to let theta equal S over A. Okay. Let me make sure I gave you that definition. Yeah, TDS. I did give you that one. Okay. I don't like doing it this way, but I guess you may have a problem like this, so I guess I should do it. All right, so then R of S now becomes A, the cosine of S over A, I, plus A, the sine of S over A, J. So therefore, when I find T, let's find R prime first. T is dr dt. No, this is how to be dr ds. So T is dr ds. I need to find dt ds, which will be dr. Oh, T is dr ds. So now I'm going to get A times minus 1 over A, the sine of S over A, I, plus A times 1 over A, the cosine of S over A, J. So this is now T, now is negative sine of S over A, I, plus the cosine of S over A, J. Okay, so therefore dt ds now becomes minus 1 over A, the cosine of S over A times I, plus, nope, that's a minus 1 over A, the sine of S over A, J. And then the length of that dt ds is the square root of 1 over A squared cosine squared of S over A plus 1 over A squared, the sine squared of S over A, and that turns out to be 1 over A. And this is the curvature. Okay. So now we want to define motion in space. So we did arc length and curvature. All right. All right, so now we want to describe velocity and acceleration vectors, tangent and normal components of acceleration. And we are not doing Kepler's law for this in this. We don't do that. We don't bother to worry about that. Okay, so let's talk about the unit normal. Oh, this is a new section. I need to stop.